Thank you. So, very good afternoon, good morning to everyone. I'm Dr. Sangeeta. First of all, I would like to thank you, Roberto, for this opportunity and conducting this very innovative platform for the landslide research. So, I'm Sangeeta. I'm doing my postdoctoral research at University College Dublin. And previous to that, I have completed my PhD from IIT Roorkee, India, and I have worked on the landslide susceptibility generation mapping. So, today I will present a topic influence of anthropogenic activities on landslide susceptibility, a case study in Solan district, Himachal Pradesh. So, in this presentation, I will start with the global and Indian scenario of landslide. Then, I will discuss some research gap in this topic and the main objective of this research work, followed by the data used, material, and methods. And I will discuss the result and the future direction and the conclusion. So we all know landslides are very severe, geohazard, and frequently occur in countries including China, Italy, Indonesia, Japan, Philippines, United States, Switzerland, and many more. And these hazard is not only limited to this country; they are also occur the countries which are straddled by the Himalaya, like Nepal, Pakistan, India. If we talk about numbers, in past 2 decades, approximately 4.8 million people have been affected and more than 18,000 people have lost their life. Now coming to the Indian scenario, here in this world map, you can see the position of India, which is the most affected in terms of fatal events related to landslide. And if we talk about the situation of India inside the India, about 15% of the land area is prone to landslide. And most of the area is falling into northwest and northeast Himalaya. Here in this Indian map, you can see these yellow points are the distribution of the landslide. Here you can see 34% falls in a northwest Himalaya and 43% falls in a northeast Himalayas. Before coming to the presentation, I will discuss what is landslide susceptibility zonation, how we develop these maps. So, landslide susceptibility zonation is basically subdivision of the terrain into zones that have a different likelihood for the landslide occurrence. In order to develop landslide susceptibility zonation map, we follow the philosophy given by Brab in 1991. The past and the present are the key to the future. So here, the past is the landslide inventory, which is the past record of the available landslide events. And the present is the landslide controlling parameter, which are the inherent controlling parameters for the landslide. So with the help of this two input parameter, that is landslide inventory and landslide controlling parameter, we use some landslide methods and we develop landslide susceptibility zonation map. And with some validation methods, we check the accuracy and the acceptability of the maps. So landslide could be triggered by different triggering factors. Some are natural, some are anthropogenic. In a natural, the common triggering factors are rainfall, seismic activity, and for the anthropogenic parameters, some factors like road development, tunneling, hydroelectric power projects, and climate change. So many recent literature suggests that anthropogenic activities alter the topography. Altering the topography means changing the terrain of the area, which eventually lead to the unstable terrain and become a landslide disaster. Many studies have reported that road construction or widening of the road and land use land cover changes have a significant influence on the landslide occurrence. So there is many studies which have covered the topics related to the rainfall induced landslide or earthquake induced landslide, but in the literature there is still a gap which on the detailed information about the anthropogenic activities and climate change, how these factors affect the landslide occurrence. So this is the main research gap in this domain. Based on this research gap, the main objective of this work is to understand the Influence of anthropogenic activities on the landslide susceptibility. So for this work, various inherent landslide positive parameters, which include the topography, geology, lithology, and different other parameters, with the dynamic anthropogenic factors used to develop the landslide susceptibility zonation map by the help of the statistical based frequency ratio method. So for this work, I have selected a area which falls in Himachal Pradesh, India. This is the Solan district. And why I have selected this area? This area have the very socio-economic importance in the region. And this area is also known as the gateway to the Himachal Pradesh because one of the major highway NH5 passes through this district. So this is the location map of the study area. Now coming to the data, material and methods. As I have discussed earlier, to develop a landslide susceptibility zonation, we require two basic input parameter. One is landslide inventory and other is landslide controlling parameters. So first step is to collect in the data, processing the data. So here is the different sources from where I have collected the raw data and processed them with the help of ArcGIS and different tools. So the first step to collect the data, process the data, and then I have used some statistical method, that is frequency ratio, and develop the landslide susceptibility zonation map and validate this map with the different techniques. And at the end, I have analyzed the impact of anthropogenic activities on the landslide susceptibility zonation and how land use land cover affected the landslide occurrence. So there are several methods available by which we can develop the landslide susceptibility zonation map. There is two main category, qualitative and quantitative. So in a qualitative method, in the absence of landslide inventory, basically we use the distribution free or geomorphic analysis. This is basically based on the expert judgment. And the other category is quantitative, where we use the correlation between the landslide controlling parameters and the landslide occurrence. So in this particular work, I have selected a statistical based bivariate method. So in this, we correlate a landslide distribution with the landslide controlling parameter. Then we normalize this value from by using relative frequency ratio, and then use the weighted linear combination to generate the landslide susceptibility index. So this is the first input, that is landslide inventory. How we define the landslide inventory? Basically, this is the detailed register of the distribution and characteristics of the past landslide. So I have categorized my landslide inventory in a two category based on the triggering parameter. One set is rainfall induced landslide and the other set is human induced landslide. So how we categorize the human induced landslide? This is the landslide that are directly or partially triggered by the anthropogenic activities. This anthropogenic activities could be the modification of the topography, change in the water circulation, or change in the land use land cover. So based on the different driving factors that are slope profiling, urbanization, or using the different vibration or explosive technique, they alter the terrain, they alter the stability of the slope. So based on this parameter, like road in a road widening, sometime road cutting at a very steeper angle, or the disturb the original natural stabilized slope. So based on this driving factor, we categorize a slope as a human-induced landslide. So a total 1,030 landslides have been used in this study in a form of polygon data. Now coming to the landslide positive parameters. So here the first set is the landslide positive parameter, which are the inherent parameters. So in this, I have selected three topographical factors: slope angle, aspect, and curvature. Then the lithology and lineament and drainage. So each controlling parameter affect the landslide in a different way. So first we have to understand how these parameters are going to affect the landslide, how these parameters are related with the landslide. So for this, we use the frequency ratio to find a correlation between the parameter and landslide. So for example, slope angle is if we increase the angle of slope, the chances of landslide would be higher. Similarly, for the aspect in a Himalayan region, south-facing slopes are more prone to landslide because they receive the higher rainfall. Similarly, the other parameter like structural discontinuity in terms of lineament has been used. And for the anthropogenic factors, the dynamic, which are dynamic in nature, change year by year or month by month, we have selected land use, land cover for the 5 years, ranging from 2017 to 2021. So here are the two land use, land cover map. One is from the 2017 and other from the 2021. So here you can see area covered by tree decreased by more than 12%. Here in the bar chart, you can see, and the other like crops built up scrub or the bare land has increased. So landslide incidences have increased significantly in both built area and the bare land. From year 2017 to 2021, there is increase in the landslide occurrence. Now coming to the landslide susceptibility generation mapping. So as I have mentioned earlier, we have select the input parameter like landslide inventory and landslide controlling parameter. Then we use some methods like frequency ratio method or any other method to find the correlation. And then we use the weighted linear combination to generate the landslide susceptibility index range. And we use some classification method to divide our landslide susceptibility zone in a different groups, which ranging from very low susceptibility to very high susceptibility. So the very fundamental rule to check if we have developed the accurate map or not, our very high susceptibility class should have the lowest area and the highest number of landslide occurrences. Then to check the accuracy of the map, we use validation technique. Here I have used the success and prediction rate curve. As I have mentioned earlier, I have categorized my landslide in a training and testing data set. I have keep 80% to train the model and 20% to validate the model. So here the success rate curve which use the training data set and the prediction rate curve use the testing data set. So here you can see the accuracy, the area under curve is 0.79 for the training data set, that is success rate curve, and 80% for the prediction rate curve. Now coming to the evaluation of LULC and LSZ. So here are the two landslide susceptibility zonation map. One for the year 2021, which used the land use land cover map for the same year, and the other which used the land use land cover from the 2017 year. So here you can see the map which used the land use land cover map for 2021. In that, 23% area falls into high susceptibility and very high susceptibility classes, and 48% area falls into very low susceptibility and low susceptibility classes. If we compare this map with the landslide susceptibility zonation map from the 2017, we can see the high susceptibility and very high susceptibility classes have been increased by 15%, and the low susceptibility classes and very low susceptibility classes reduced by the 7%. So this basically signified the impact of the change in a land use land cover over the time and how this impact the landslide susceptibility zonation. Now coming to the landslide analysis on the national highways. So for this purpose, we have selected 4 different national highways and we have created a 1 kilometer buffer along the national highway, then conduct the landslide analysis. So basically road construction, which include the new roads or the widening project, are one of the main anthropogenic activities in the Himalayan region. So here You can see the first one is the National Highway 5, which is the main highway which passes through this study area. So a total 232 landslide are falling in the buffer zone, which is 1 kilometer. And out of this, 83 landslides are due to anthropogenic activities. So here's some pictures from this area. This is the event in a 2021. So the main conclusion from this study, there's three main findings. The one is landslide susceptibility is higher along the road network, and most of the landslide which are along the road are not the rainfall induced; those are the human induced landslides. And more than 50% are triggered due to the anthropogenic activities. So one of the main reason in the area is anthropogenic activities. So area belonging to high susceptibility classes have been increased, whereas lower susceptibility classes have been reduced. So in future, the inclusion of landslide susceptibility, inclusion of the land use, land cover, the changes in the terrain should be included in the analysis of the landslide susceptibility zonation. So these are the some key references I have used in my presentation. This is the paper I have presented today. You can find this for more details. So with the note, we cannot stop disaster, but we can be prepared to survive them. With this note, I will end my presentation. If you have any questions, you can drop in a chat box or you can contact me on this email IDs. Thank you.